All right, let's get into a real scientific detective story today. And I mean, this one took almost half a century to solve. It's this fascinating mystery about how a virus, one that pretty much all of us have, could actually hold the secret to predicting a really rare but deadly form of cancer. So here's the big question. Can a virus that is infected, get this, over 90% of us, actually predict your risk for a deadly cancer? The virus we're talking about is Epstein-Barr. You might know it as EBV. It's super common. Most of us get it, and usually it's no big deal. But, and this is the key, for a very small number of people, their body's reaction to this exact virus holds a clue. It's like a warning sign for a rare throat cancer called nasopharyngeal carcinoma. So the question is, how on earth did scientists even begin to connect those dots? Well, our story really kicks off back in the 1970s. In places like Taiwan, doctors were noticing these unusually high rates of nasopharyngeal carcinoma, or NPC. And they started to see a pattern, a really strong association that would become the very first clue in this whole investigation. So they started looking, and a study back in '75 that was looking at the immune response to EBV found this. Huge difference. Check this out. A full 55% of the NPC patients had these incredibly high levels of antibodies fighting the virus. And in the healthy folks they compared them to, that number was under 31%. I mean, that's not a small difference. That is a massive signal that something was going on. For some reason, the bodies of these cancer patients were just reacting completely differently to this virus. And the sheer scale of this was just staggering. That same study figured out that people with these high antibody levels had, listen to this, over 40 times the risk of having NPC. This wasn't some subtle little clue. It was like a giant flashing neon sign pointing right at a connection between the virus and the cancer. Right, but here's where it gets tricky. This discovery immediately brought up that classic scientific puzzle, you know, the chicken or the egg thing. Did the high antibody levels mean the virus was actually involved in causing the cancer? Or was it possible that the cancer just happened to develop first and the tumor itself somehow kicked the body's immune system into overdrive, making it overreact to a virus that was just kind of sitting there dormant? You know, correlation isn't causation. And the researchers back then, they were totally aware of this. A paper from Taiwan in 1977 studying this whole thing basically said it outright. They knew they had a powerful clue. But the case for EBV being a direct cause, it was far from closed. They needed better evidence, something more specific, like a clearer fingerprint of the virus at the scene of the crime. So the investigation moves into the 80s and 90s. And to solve that chicken or egg problem, scientists knew they had to dig deeper. They couldn't just look at the overall immune response anymore. No, they needed to find much more specific viral fingerprints to prove this virus wasn't just some innocent bystander. So they zeroed in on specific parts of the virus, like an enzyme called EBV DNase. Now, this enzyme is absolutely crucial for the virus to make copies of itself. So the thinking was, hey, if the body is making antibodies against this specific replication tool, well, that might be a sign that the virus is active and involved, not just a generic immune flare-up. Okay, but identifying this target created a whole new problem. How do you test for it in thousands of people? The big breakthrough really came in the 90s. Researchers figured out how to use common bacteria, like E. coli, as these tiny little factories to churn out pure EBV DNase in the lab. This pure protein then became the key ingredient for a reliable, large-scale blood test called an ELISA, which could finally make mass screening a real possibility. And now we get to the pivotal moment, the real turning point in this whole 45-year story. With a reliable test finally in hand, scientists could design the study that would find the smoking gun to see if these antibodies could actually predict cancer risk before the disease ever showed. And this was the absolute game changer. A huge study published in the New England Journal of Medicine back in 2001. They enrolled nearly 10,000 men in Taiwan, took their blood, and then just followed them for up to 16 years just to see who would develop NPC. This kind of long-term, forward-looking study was exactly what they needed to finally answer that chicken or egg question. And the results? Whoa. They were absolutely stunning. The men who had these specific EBV markers in their blood right at the beginning of the study were way more likely to get NPC years down the line. If you had just one of the markers, your risk went up by 4 times. Okay, pretty significant. But look at this. If you had 2 markers, the risk didn't just double. It went through the roof. We're talking nearly 33 times higher. Just incredible. The study's conclusion was definitive. It was the smoking gun everyone had been searching for. These high antibody levels, they weren't a consequence of the cancer, they were a predictor of it. The immune system's strange reaction to EBV was showing up in the blood long before any clinical signs of a tumor. The case for a causal link was now overwhelmingly strong. So, with that causal link pretty much established, the final act of our story really shifts into the modern era. The question wasn't if the virus was involved anymore, but how? Could we use this amazing knowledge to build an even better, more precise test? The next couple of decades were all about refining that signal. The next big leap forward came from some seriously cutting-edge tech. A 2018 study used something called a custom protein microarray. I want you to picture like a lab on a microchip. It lets scientists test a single drop of blood against nearly the entire library of EBV proteins. We're talking 199 different ones all at once. This gave them this incredibly high-definition picture of the immune response, like never before. And what this powerful tool found was just remarkable. It identified 133 new antibody differences between the cancer cases and the healthy controls. Now, these included 60 of what's called the IgA type and 73 of the IgG type. You can think of IgA and IgG as different kinds of security guards in your immune system. So finding reactions from both gave scientists a much, much richer set of clues to work with. So, how much better was this new information? Well, the results were really impressive. This chart shows the predictive accuracy. That's basically a measure of how well a test can tell who's going to get sick versus who's going to stay healthy. The older biomarkers, they were already pretty good, about 82% accurate. But this new signature, built from the best of that microarray data, boosted the accuracy all the way up to an incredible 93%. But let's be real, a 14 antibody signature, even though it's super powerful, is way too complex for a simple everyday screening test. So the final challenge was to take this amazing, rich discovery and boil it down into something practical. And that was the whole point of a 2020 study, to find the absolute core of this signal and build the simplest, most accurate test possible. And the result was just, well, it was really elegant. After sifting through all that complex data, researchers found that the predictive power of that entire 14-part signature could be boiled down to just 2 key markers. A new model using only antibodies against 2 proteins called LF2 and BGLF2, that was all they needed. So how well did this simplified 2-marker test actually work? Incredibly well. It was able to tell the difference between NPC cases and healthy people with a stunning 98.4% accuracy. Just think about that for a second. After a 45-year journey that started with this kind of vague clue, scientists had created a super precise 2-marker test. It's a truly incredible scientific achievement. Which brings us to our final thought here. After this 45-year quest, piecing together all these clues from epidemiology, immunology, molecular biology, we now have a test that can spot high-risk individuals with remarkable accuracy. And this leaves us with a really powerful question. Are we finally standing on the verge of a new era in cancer prevention where a simple blood test can actually catch this disease before it even begins?